In this lesson, we are going to look at the corollary of circle theorem 1. Remember, the word corollary means a result, an immediate result. So this is a resultant theorem. That's a resultant theorem, immediately following circle theorem 1. So this theorem, because it's corollary, it doesn't need much proof. It's just general reasoning. Logic will tell us that from theorem 1, which says a line drawn from a center perpendicular to a chord will bisect the chord. That's what we saw in the first theorem. So this is corollary. It's saying a line joining the midpoint of a chord to the center of a circle is perpendicular to the chord. What it means is we already have the midpoint, so we don't need to establish it by construction. At the same time, we are going to see that the line drawn from the midpoint is going to be at 90 degrees. Remember, perpendicular means 90 degrees or right angles. So that line drawn from the center of the circle to the midpoint is going to be at 90 degrees to the chord AB. So here, we don't need to do any complicated construction, but just checking this line here, we can see that the length of the line is 7 centimeters, and half of 7 centimeters is 3.5 centimeters. So we can get the midpoint by simply measuring. So let's call this point E. Now, if we join, E is the midpoint of chord AB. So if we join the midpoint E to the center of the circle O, we create a line segment OE. This line segment is said to be at 90 degrees to AB, the chord. Now, this we can check, we can verify with a protractor. Now, placing the center of the protractor at E and making sure that we line this baseline of the protractor with line AB, we can see that the angle is at 90 degrees. Let us just extend this line so that the reading is going to be accurate. We extend line EO, so center of protractor at E and the zero line on line AB. So we can read from 0 to 90 degrees. So this confirms that this angle OEB is equal to 90 degrees. On the other side, there is another 0 here on the protractor. We can also read from this 0 and we get to 90 degrees. So it's now safe for us to say angle OEB is equal to 90 degrees and angle OEA is also equal to 90 degrees. So this is the corollary theorem. Now, to verify that this angle is 90 degrees, we can also use the set square instead of a protractor. This angle of the set square is 90 degrees. So we can push in the 90 degree angle of the protractor into the angle OEA. So we can see that the arms of the angle are matching the sides of the protractor. So this angle is 90 degrees. On the other side, we can also push in the 90 degree angle into angle OEB, and we can see that the angle matches the sides of the set square. So that's how we can verify that the angle is equal to 90 degrees. Okay, so this is the corollary theorem to theorem 1, circle theorem 1. Now, it's very easy reasoning that Once you understand Theorem 1, cycle Theorem 1, now it follows that you just join the center of the chord AB, which is center E, to the center of the circle, which is O. Now the line segment so created, which is OE, is going to create an angle of 90 degrees either way. So it's very safe for us to say angle AEO is equal to angle BEO, and this is equal to 90 degrees. Okay, so that's the corollary theorem to cycle Theorem 1. At this point in time, let's look at the application of this corollary theorem. It's not very different from the application of the theorem itself. Now, suppose we are given this question, okay, which says, in the circle below, O is the center of the circle, E is the midpoint of a chord AB, the radius of the circle is 15 centimeters, and EB is equal to 12 centimeters. Now, here's the circle with center O and chord AB. E is the midpoint of chord AB, and we are told that EB is equal to 12 centimeters. So EB is equal to 12 centimeters. Now, because E is the midpoint of AB, AE is also equal to 12 centimeters. We can actually update the diagram. Now, the radius is given as 15 centimeters. So we need a construction so that we see the triangle clearly. We have to join the center O to end B of the chord with a straight line, and center O to end A of the chord with a straight line. So OB is the radius, OA is also the radius. So OB is equal to 15 centimeters, and OA is also equal to 15 centimeters. Now, because the area is wanted, the question said calculate the area of triangle OAB. We have triangle OAB. The area of this triangle is required by the question. So to calculate this angle, we can see that here, with the knowledge of the corollary theorem, we understand, even if we are not given, that angle BEO is equal to 90 degrees. It is 90 degrees. And angle AEO is 90 degrees as well. So we have two right-angled triangles sharing a side OE. So triangle OAE and triangle OEB. These are congruent triangles sharing a side OE. So now, what we can do is, we know the basic formula for calculating area of a right angle triangle, or if we are given a perpendicular height. So OE becomes the perpendicular height of the triangle. So let's call it H. H is the perpendicular height, perpendicular because OE is meeting AB at 90 degrees. So this is a perpendicular height. So the basic formula for calculating area of a right angle triangle is, let's pick one triangle there, and we say in triangle OAE, triangle OAE, then we can actually see that we are given one side which is 12 centimeters and the other side which is 15 centimeters. The side which is 15 centimeters is opposite to the right-angled triangle. So this is the hypotenuse, the longest side of the triangle, 15 centimeters. So we can apply Pythagoras theorem and say r squared is equal to x squared plus y squared. This is the reason is Pythagoras. We write the reason as Pythagoras. So in that triangle, we can see that the radius is 15 centimeters. So we say 15 squared equals to x. Our x is 12 centimeters. So it's 12 squared plus y squared. Y is going to be the h. So we can actually substitute for y squared and write it as 15 squared equals to 12 squared plus h squared. Okay, because we are looking for h. Now, 15 squared is 225. So 225 equals to 12 squared is 144. This is plus our h squared. Now, we transpose 144. So we'll see that our h squared will be equal to 225 minus 144. So this is equal to 81. So it means h squared is equal to 81. Now on the left we've got a square, on the right we've got a square. Now what we do on the left is what we do on the right. So here we have to find the square root of the left side. We also find the square root of the right side. So we'll see that the square root of h squared is h. Now this is equal to the square root of 81. Now which is equal to 9 centimeters. So we find our h here is 9 centimeters. So now we can substitute into the basic formula for finding area. So we say area is equal to half base times perpendicular height. So remember, this is our h, which is the same h as that green h. That's the perpendicular height in the diagram. So we are going to say this is equal to half multiplied by the base here is AE plus EB, which is equal to 12 centimeters plus 12 centimeters. That will give us 24 centimeters multiplied by our perpendicular height, which is 9 centimeters. Now, without even picking a calculator, it's easy to just get half of one of the numbers here so that we get rid of that half. So half of 24 is 12. This is multiplied by 9. So 12 times 9 will give us 108 square centimeters. Remember, this is area, so we have to square the units. So the area of triangle OAB is equal to 108 centimeters. Thank you for watching. Please subscribe so that you get notification of other videos. All the Euclidean geometry theorems are going to be covered with their converse theorems and corollaries. So this series is going to take you through the original or the basic Euclidean geometry as it was done by Euclid. Thank you for watching. Remember to share, remember to comment, remember to like.